Want to make a benchtop power supply that you can test LEDs, sensors, or even gauges? Sounds like something you'd be interested in? Let's do the video. Now before we start dissecting this thing, I want to show you guys how to turn it on without being put into the computer. Now on your power supplies, you got all the blacks here, which are grounds, and we'll go into the other colors here in just a bit. But that one single wire right there is green. That one green wire, if you take you a jumper, this is nothing more than a solid piece of wire right here, and just bend to a U. If you take you a jumper, this goes into the green, this one goes to the black right next to it. You ground out that green. And get it to stay in there. There it goes. And you hear the fan running. See it going right there. So now that we got the power supply turned on, oops, DC volts. So what we're going to do is we're going to take our test leads, we're going to look at this. We're going to get my leads, need to treat them like chopsticks. Put your black lead into black wire here, which is going to be your ground. Hold that there. Take your red lead, touch your red wire, and you've got 5 volts. See that there? I had my hand off in the way, didn't I? So then we take your red lead, and we're going to touch the orange wire right there. What volts do we get? The 3.3. Okay. Now, so we need to flip side this. And again, on the back side here, you can find yourself another ground, which orange, orange, black, orange, orange, black, ground here, and white wire. Touch it. We got, well, I'm going to say 12 volts, but close enough, 11.96. But one thing about using a power supply from a computer, if you notice, look how steady the voltage is. It hits 11.96 and it sits there. It's completely clean power. Versus some power supplies, the voltage jumps up and down, does all kinds of weird stuff. Well, it's jumping up and down now because I did hold my leads. Get back on here. So you see, it comes right back to 11.96. And some of your power supplies, and I say power supplies, I'm just talking about the universal, hey, we're going to get 12 volts out of this type thing, will jump up and down a few, tenths of a volt or whatever. One thing about using a power supply out of a computer, you normally get good, clean voltage to test your equipment with. So look what we got here. We got 12 volts, we got 5 volts, and we got 3.3. 12 and 5 are usable volts for automotive stuff. 12 is going to be for doing your LEDs and stuff like that, and your 5 volts will actually test sensors. So that's the only two we're going to use. The 3.3, I can't think of anything right off the top of my head right now that would be usable for. But when we start getting into the wiring to cut stuff out, I'm going to take the 3.3 and I'm going to set it up to where if I want to come back and tie something into it, I can later. But for right now, I'm not going to use the 3.3. We're just going to worry about the 5 volt and the 12 volt. Now, you want to turn the power supply off? Simply take that wire, and I don't know if the camera picks it up or not, but the fan just turned off. And just to reiterate and prove, put that on ground, and put this on red. And before we would have had 5 volts, and right now we got nada. So the power supply is turned off. Now at this point, what we're going to do is we're going to take this thing apart and see how we can arrange our little binding posts here to tie it to the wires so we can make it a functional power supply to test gauges, to test sensors and stuff with. So, where's my flush cutters? Here we are. Even with that, some of this wiring right here, a lot of it I will cut completely out and will not use at all. And see, that's it there, right there. Okay, so I'm going to take these screws out. Now, I know in the video I didn't include how to pull it out of the computer. That varies so much from one computer to another depending on what kind of case they are. I could show you one style case and it'd be totally different when you get to the next computer. This came out of an old Dell computer that got junked out. Pull this over and see what we got going on here. I'm gonna go ahead and unplug the power here because if I do something wrong, stick my finger in the wrong place, that will hurt. Yes. So let's unplug it before we get too crazy here. Actually, that should have been my first step. Alright, so I think I need to take this. Which way do I need to go with it? Because we got a transformer right there, so I need to take a light over this way. Okay, so that was like this. So what I'm looking at, I need space to put these in place. So it looks like all I need them are like right along in here because that's where I'm going to have the room. And that'd be the waving and stuff in here. So they'll have to go on this. Right there's a little groove that was holding that wiring in place right there. So this will sit over here. It'll be on this side, on the label side. So now, with that being said, let's see how much of this junk we don't need. So we'll cut that, get that out of the way. Let's see. And a lot of these wires are going all the way down into the board, way down here. So all this mesh right here, I'm not going to use any of it. So I'm going to flush cut it right off to the board right here, and we'll just get our power from these wires here. Now, some people's going to be thinking, okay, hey, if you use more wires, you can pull more amperage. That's not true, because you see right here, input, output, on the 12 volt side, you got 18 amps max. So, I mean, honestly, that's enough to turn on maybe a radio, not an amplifier, not a power amp or nothing like that, but just turning on a stereo, your in-dash stereo, to see if it turn it on, does it work, something like that. But you're not going to crank it up depending on how much amperage it pulls. And let's see, then the 5 volt rails have 2 amp max. And that one has a 22 amp max, okay. And even on 5 volt, I mean, you're going to be testing sensors and stuff like that. So again, you're not going to be pulling a lot of amperage. So to require a lot of heavy cable is not going to be necessary. So with that being said, you want to be careful snagging, cutting your wires, because I want to leave the fan intact here. So I'm going to get in here, cut this out, separate my wire from the fan here so I don't accidentally cut it. There, we got that out. Cut that. So this whole pigtail here, this whole harness, whatever you call it, is primarily going all the way through here. Again, here's 2 wires right here that's going over to your cooling fan. Leave them intact. But I'm going to get right along through there and start weeding out them wires. I'll tell you what, let's just do it this way to help us a little bit. Just kind of clear them out of the way, then we'll work with it a little easier. No particular length, I'm just cutting to get this big mess of wires right here out of my way. Now, if you want a power supply that puts out a lot of amperage, something like that, you're going to have to purchase that, or you can rig something up off of a car battery or something. The only time you really want something to put out a lot of high amperage if you're testing a car stereo and amplifiers and stuff like that. And that kind of takes its own style, dedicated power supply, not just a computer power supply, because of the amperage load. Got that one out of the way. Now we got that spaghetti. We don't need it. Toss it aside. Again, here is your 2 wires for your fan. Make sure you don't cut that. And all these little short tails, cut them as close to the board as you possibly can. So for now, I want to kill the camera. I'm going to trim them out, and I'll be right back in just a moment. You can see over here we got a scattered mess of all the wires. Now look real close. You can see right through here where I trimmed them out. But be careful, because your grounds are super close to the ones to this tail right here that we're going to use parts of. So don't get in here and get all froggy with your cutters and start snipping too much. Pay attention to which wires you're cutting out. Therefore, you'll leave your main piece here that we're going to use here in just a moment. Okay? And there's your fan wire. Make sure you don't cut it. And these hiding back here in the corner, I could have taken the board off that, but I cut them up high enough that they're not going to be, touch anything down here, and they're going to be alright. Just trim them down. Now at this point, we need to figure out our wiring here, what we're going to do with it. Got that cut off. Now let's separate our wires. Get our reds together here, pull them out. And that blue right there is our 3.3 volt that we're just going to kind of let it ride for a moment. And there's our green wire, which is, if you remember, that's what turns the power supply on. So we need that, and one of the grounds. It don't matter which one. I'm just trying to get one that's going to be the neatest in the harness. These 2 right here, we'll keep these 2 out separate. Because that's going to go to our switch to turn it on and off with. Oops, and that is not a ground. That is purple. We don't need that wire. Green. And most of us will look down inside here where the harness bundles up and down inside that. It's just me being OCD, I guess. I'm trying to find the black wire that was the closest to the green, so it kind of keeps the wiring as clean as possible. Now let's tie these 2 together, because it's going to be going to our power switch. And you know, I'm not 100% sure what the purple's for, but I don't care because we're not using it. I'll test it in a minute. We'll see what it's for. Okay, now we get our oranges. Put them together. We got a gray hanging out here. I don't remember right off what those are for, but we'll test to see if they have voltage going to them or something like that. Set them off this. Get over here. Just nah. Alright, so we got an orange here, black here. So we need 1 black for our turn on lead. 2, 4, 6, and we got how many binding posts? 2. So let's see if we can do 3 wires per binding post. Let's bring that one up here. Again, I'm just splitting the harness up to make them even down there. So at this point, I need to figure out if I want all my stuff right here on this face that's going to be here. This is where I need to set the length of my wire. We'll cut them off and bind them together right here to set them up on this face. So I've got these 3 blacks here, and what I'm going to do, trim these down. And say they're about right there. And try to keep you plenty of slack inside here. You don't want to pull it super tight. And right there. Don't need those. And you see what I'm about to do. So I'm going to take all the blacks here, these here, and these. I'm going to put the ends on them, and then I'm going to go ahead and do the oranges and put them together. And basically, I'm just going to put, see, it's going to be 3 wires. And I'm using these little ring terminals right here. So if all 3 of those wires, and I wrap them up, they stick in there, it'll be just fine. But if they don't, I'll take one of them out till it does fit. Here we got our wires coming up through the ring terminal right there, sticking up through there. Take our crimpers, Use the right side. It actually needs to go like this. There's actually a right and wrong way to crimp terminals, and I've got videos on that too. These are not my favorite crimpers. My good ones are right there in the shop, but these will work for now. So, okay, so you see what I'm doing. I'm going to go ahead and do this group of blacks here. Then I'm going to get this group of oranges together, do them the same thing. So just get all your wires grouped together. Like you got all these reds here. You're not going to need them all. So you just get down here and sort them out and figure out which ones you're going to use. And I'll show you that here in a moment after I get through doing this. And I'll show you why I did what I did. Okay, let's get you caught up. We got the wires all crimped up here. Obviously, still not plugged in, so before you guys get all freaky and I'm about to get shocked or something. So we got them all tied up. I've got green and black here separated, ready to go tied together, because that's going to be our turn-on leads for our switch, remember? One thing, I said I wasn't sure what wire was going for what, or because this purple wire, you can follow it down on the board of the power supplies, oftentimes they're marked. That's a 5 volt there. So we got 5 volt coming off our red, so we won't need the purple. That gray wire is going down there, and it says PG. I have no idea what that's for, right off the top of my head. And then we got the blue wire. Wiggle it, it's right there, and that's negative 12 volts, which we will not need. And so then we leave the little thin brown wire, which is a 3 volt sensing wire right there. So those wires there we're not going to need. So I'm going to chop them out real quick. And again, that's the blue, purple, gray, and brown. I don't need those wires, so I'm about to get them out of my way. But remember, the green, the black, we got to keep them with the rest of these right here. And that's what we'll tie our binding post and switches to. So now we've got the wires cleared out and everything, and these right here bound down. Let's tuck them in behind here for right now. We're just getting them out of the way. Look, no power, so we're not turned on. We're not going to be electrifying anything. We're not electrocuting ourselves, all that fun stuff. What we got to figure out is where to put our binding posts. Now, here's what our limitations are. You've got all this electronic gadgetry inside here. Look at it from this angle. You've got a capacitor sitting up here, so you can't get below that because you'll hit the capacitor. Over on this side, we're wide open, but we got a limitation here. We got a transformer in the way, which is limiting our width. Our binding post, too wide to fit in there because it's going to be all up into the transformer. I mean, yeah, your depth of mounting is about like right along in here, which will probably give us room, honestly, but we got more room on this side for these, but we got to make sure we mount higher than the capacitor so we don't get in the way of it. So what I did was, top of the capacitor, imagine projecting a line straight across, draw a line there. But once we put the cover back on, we're going to cover that up so we can't see it. So just simply take it and project it over like this. That's going to give us a limitation from the top of the capacitor here, knowing we got to put our binding post above that. Okay? Yeah, righty. So now we need to take, remember this right here is where that harness came up through on this corner. So we got to roll that around. Bring it down, back over. And it don't have to go right back into the slots to get our idea of what we need. So now what we do is take that line, project it here, knowing we got to come, all of our binding posts has to be above that. So we go one here, thereabouts, and one about right there. And that's going to give us our clearance we need on the inside for our wiring plus mounting capability. We're above that capacitor. Our transformer is about, if you look, right there's the screws for the transformer. And the top of the transformer is about, there's a hole right here. So right there, project this across here. And about along there. And again, stay marker. Binding post there, binding post there, we're clear. Which leaves room for a switch to come over here. Sound good? Cool. So, with that being said, we're going to put one set of binding posts right here, and you see how technical I'm getting with, I'm going to measure, make it perfectly centered and all this fun stuff. Not really, no. So, dot there. Dot there. If I put it in, that's above that. So I'll bring this up a little bit, right there. I'm on this side where the transformer is. Well above that one. And you can make it, if you want to get really nerdy about it, you can make sure it's perfectly level, whatever. Float your boat. Right there, right there. There's that. What did I do with it? Then I take my center punch. Right there on that hole. That. 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 There he goes. So that's where I'm going to drill those 4 holes for my binding post. Now for my power switch, and again, here is your transformer here, because you see the screw locations coming across here, which means I need to be to the inside of that, project that down here. Remember, I've got plenty of clearance inside there. We looked at that a moment ago. So which means I've got right along here, I can put my power button if I want to. So I'll just mark on that center tab right there. And center punch that. I need to tighten the spring up on the center punch. There she goes. These center punches right here, sometimes that right there comes loose. If it does, it doesn't want to punch right. So, ta-da! By movie magic, the holes are there. Actually, I drilled it with that right there, but yeah. So now what we got to do. So now our switch we're going to turn it on. Those is 3 poles. It's actually it's an on-off on switch. On, off, on. So basically what should be going on, this is going to be your common post, and this right here is going to be more than likely here to here will be that position and so on. But what we do, we can take our meter and figure it out. So what you want to do is take your meter, set it on continuity, which means whenever you touch these 2 leads together, it's going to go beep. Ah, look, it ain't beeping. So what you do is, on this particular meter, go from off to the little diode and I don't know, I guess you call it a speaker icon, sound icon, whatever that is right there. But right now it's not going to do it because it's set up to do the diodes. So what you need to do is push select. Now when I touch the leads together, that means we got current. So let's test it out. Right now the switch is in the off position, which means we should not have any type of contact across any of the posts. We do not. Now notice it's got a single line, double line. And now I'm going to use this switch because that's what I got. I mean, use a standard toggle switch or whatever kind of switch you want. That's just a single position. But if you happen to only have one of these on-off on switches, 2 position switches, I want to push the single line as being the on position. So now we're going to figure out which poles are active. So the center should be our common pole. Right there. This side's pushed in, which is pretty common on your switches. This side right here is the side pushed in, but this switch right here, this pole here is going to be the active one, and this being your common pole between the 2 here. Which means, common pole means, again, we're set on continuity where it makes the beepy sound. I'll touch the lead there if I can prevent from pushing them. Like sometimes I need to grow another arm. So that side's pushed in, which means this side's active. Now let's push this side in. This side should be active. This side is not. See? That's the common pole between the 2. I mean, of course, I'm touching is beeping, but so that side's pushed in. This side's active. That side's pushed in. This side's active. So therefore, whichever one I want to decide to use, but I'm going to use that single line. But if you use a regular on-off switch, it'd be a lot easier on you. But this is what I found, and I nosed around all my switches for whatever reason. I think I've used them all up. And so that's what I'm going to use. So, yep, anyway. We'll pop that baby in. So, right there, and I'm going to push it in. Now let's put our binding post in place. Now, just for the sake of, I don't know, consistency, I'm going to put red on this side out, on the outside part. But what you want to make sure is your posts do not touch the metal on the inside there anywhere. Put these in there, and put a lock washer, and one of the nuts, and the other side. Tighten those down securely so this thing does not move, because you don't want those two posts shorting out on the metal framework here. So I want to put the other one in, tighten these up, and I'll be right back with you. Now I got y'all zoomed in here because I need to show you a little detail something. Now look right here, we got this one, this post is loosened up. We got the wire right there where you can, it's got the hole right there where you stick a wire down through there. You screw it down, tighten, binding post is what it's called. Or you can do the plug-in styles on the end right here. But what you got to watch whenever you're tightening these up, you don't just do it. What you need to do is loosen these up first, like this one here's loosened up, okay? Watch this. I'm going to loosen this one up. And I intentionally did this to show you guys it's a very easy mistake to make. Right now, this is tight. I mean, I snugged it up, got my pliers to snug it up good, but look at this. I'm going to loosen this up. Look, it's loose again. Before you go to tighten this up, unscrew this, run it out, screw this in. Therefore, you're actually seating the post to this plastic ring right here, and it will not come loose on you. So you snug them up. Don't get them crazy tight because you don't want to strip or break your posts. You don't need them really ridiculously tight. So now your post, you can unscrew them, screw them, no problem. And it does what it's supposed to do, so cool. Alright, let me here. Right here, I wanted to take this apart and show you guys one more other detail that I didn't show you before I put them together, but I'm not taking it back apart just to show you. So there you go. Unscrew all this, get all this stuff right here off. Now look really close. See those rings right there? Those rings are actually setting up off of that. See how they kind of stand up off of it? If you set your holes up just right, those right there will set into the metal and prevent this from shifting around, therefore preventing your post from shorting out on the body. Now if you're using a plastic project boxes or something, that's fine. But being that we're using a metal case here, you want to be sure that these rings right here are seated down inside of a hole that allows them to engage and not allow these posts to move and possibly short out on the posts, on the body of the power supply. See right there, that lip, a step? Set your holes up just right. That will be inside there, and it'll prevent these posts from shorting out. And also, these are here kind of indexed to where, there you go. You got to turn it, lock it in. But a couple quick pointers for you, those who've never used these. Now, as you can see, well, you can't see because I've actually got a mark down here. This right here is my 12-volt rail. This is my 5-volt post. So this right here will get the white wire up here, and red will be my 5-volt. And I'm probably just going to tape this one up for right now because that's the 3-volt right there, the 3.3. I've really got no use for that, so I may end up just cutting that out and just kind of tucking it somewhere because I really don't think I'm going to use it because I can't think of anything, no reason for it. So there you go. Now the last two wires we have to deal with is going to be our green wire and our black wire because it's going to go to the switch here to turn the baby on. So just clip them off here to a reasonable length. Sometimes, because it's such a small gauge wire, and to make sure it fits down inside there better, I'll take the wire here and I'll fold it back up on its jacket like this. That gives it a little extra thickness, but you take it feed up inside the terminal like this, you can feel the resistance of it going in, so therefore you get a little bit better bite whenever you go to crimp it down. take you get your peak and you got the trough right there. The split in your terminal, put that in the trough, and they tend to hold much, much better. So there's that one. And so this one here's a little bit heavier gauge, so we'll just not fold that one over. Because I'm using a 2-position switch, on, off, on, I push the straight line in up top, it activates the bottom post, which turns it on. So with that being said, I think we're ready to put her back together. And make sure some of them got the tongue and groove type situation here. Make sure that goes together like it should. Watch your wiring to make sure you're not pinching it on any of the sharp edges of the case. Backside's in. Make sure to squeeze the backside so it don't pop back out again. Front side in, squeeze that in. And it's like we're good. Put a few screws in to hold it in place. Let me tell you something. For doing desk work like this, Mr. Seven Hands, that little screwdriver right there is, I've had it for a long time. My son got it for me. And it's got the little micro screwdrivers right there, flat, different size Phillips. This thing is so cool. Whenever I work on computers and stuff, that is the one screwdriver that I use the most. So I switch out the heads as I need them. I'll look on Amazon, see if they got one. If you guys are interested, I'll drop a link along with the other materials and stuff I use. So you get the gist of it. I'm going to go ahead and put the rest of the screws in. We'll be right back and we'll take it for a test drive. Just for the fun of it, first thing we're going to play with here is this little side marker LED like you'd put on a trailer or something. Yes, I know I got a red end on it, but I got black wire, so therefore I'm going to put it on the ground here. Things I want to close right. And being it's such a small gauge wire, I want to fold it over on itself. Put that there. Stay. Fold that over that. So my gator's got a good bite there. Now we're going to turn on the power. Boom! Look at that. Turn off power. Turn on power. Off. On. See? We got 12 volt power there. The 12 volt, like I said, is going to be great for doing it, testing LEDs, or if you're building some kind of custom relay harness or something like that. Something that's going to be low amperage on the 12 volt side. 5 volt side, that's what you're going to test. If you want to test sensors or things like that, let's see if we can wire something up for you real quick. I happen to have something in here. Looky there. Does that look familiar? All you 4.0, 2.5 people, that is the throttle body. So what we got wired up here, we're going to test the throttle position sensor. And here's a ground lead for our meter. If you want, your grounds are pretty well common across all the rails, so you can stick your ground lead in there and don't worry about having to hold it on anything like that. Put your ground lead here, kind of crimp it a little bit. The ground's plugged into this, coming over to, okay, you're looking down on top of the throttle body, obviously. Here's your auto control motor. This side's ground. This side is 5 volt input, because look right here. Here's the 12 volt rails, 12 volt post, and here's the 5 volt post. I'm plugged into the 5 volt. So I got 5 volts coming in from this side, grounds from this side. So what happens is whenever you twist the throttle body here, it cranks the throttle position sensor in different positions. It's a potentiometer. It's like it's a variable resistor, what it boils down to. The 5 volt input here, it varies the voltage, sends it back out here, going to the computer and says, hey, he's at idle right now, or he's at part throttle, he's at wide open throttle, whatever. And so what you do is to test the throttle position sensor to see if it's working correctly. 5-volt. This right here is your sensor wire that sends to the computer, like I just said. We're going to take this, wrap it around that and see if it'll stay. I could put an alligator clip on the end of it, but we're not right now. And let's see, can you see the meter? Let me see if I can reposition this a little bit. You guys get a better look. There we go, right. Let's see. Look, my little blue clip right there. It actually come in handy. Alright, so I wanted that right there so you guys can watch that right there. Now I'm going to turn this on, turn the power on. You see right now I got 0.6 volts because the throttle position sensor or the throttle body is sitting at idle right now. We're just sitting at a stoplight, getting ready to take off, or whatever your case may be. We're sitting at idle because right now your throttle blade is closed. So we're going to pick it up so we can work with it real gently so we don't knock any wires off. Again, 6.2. Now, whoom, get ready. Whoa, we're ready for taking off. Now we're going wide open throttle here. Now it's showing 3.6, so that's about right because this is a good throttle body. And you can see as I go through the sweep here, I'll do it real slow. Get my hand over here. So we go back to idle. Okay, right here at idle, hands off of it. Slowly open the throttle. Watch the throttle blade. You can see it opening. And plus you can see the voltage climb as you open the throttle. And there you go. And that's how the computer knows where your throttle position sensor is. How much throttle you got going on. I mean, right there we're cruising down the road, barely cracked open. Or we're just cruising through the woods and stuff like that. Oh, mud hole, kick it! And kick the voltage wide up and we're slinging mud everywhere. See what I'm saying? Alright. Alright, my Power Addicts crew. If you guys know someone who's a computer nerd that works on computers a lot, they're bound to have one of these things laying around somewhere that they're trashing. All you gotta do is do that jumper from the ground to the green wire. It'll kick that fan on. If it kicks that fan on more times than not, it's good. So you can grab you one of those, make you a benchtop tester for building LEDs, relays, testing relays, all kinds of cool stuff. Or repairing gauges. That's right. I know somebody's going to ask, Chuck, you can make a video on gauges and stuff? Yeah, actually I am. So stay tuned for that. So everyone, if you enjoyed this video, hit it with a thumbs up. Subscribe if you haven't. Leave me some cool comments down below. And I really appreciate you hanging out. Peace. Later, y'all.